Right. Today we're talking about surface area of three-dimensional solids. By the end of the period, you be able to determine the surface area of said solids, okay? There are 5 different solids that you are going to take the surface area of, or basically the way the IB works is you'll do several things that will lead to you actually finding the surface area, okay? And real quick, surface area, all right? It's basically around a three-dimensional figure. Okay, that's what surface area is. Like when you paint a house, you're painting around that entire house, okay? If you are wrapping a gift, the gift goes around, like the paper goes around the gift, right? All of that, those are examples of surface area, okay? So, the surface area of a solid is the sum of all the areas of its faces, okay? And realize the surface area is measured in square units. So this is where you don't want to lose that unit penalty, meters squared, centimeters squared, etc., etc. Okay? So, when you're looking at this figure here, this figure is called a what?
Rectangular prism.
It's a rectangular prism, okay? To find the surface area of this solid, you're going to need to basically find the surface area of all 6 faces, okay? Now, one thing you will notice is that certain faces are the same, aren't they? Like the bottom and the top, the left and the right, and then the front and the they are all the same dimensions, okay? So the bottom is the shape of a rectangle. What's the area of a rectangle?
Base times height.
Base times height, length times width. Basically, we're going to multiply 2.5 by 3. That will give me the area of the bottom and the top. So to figure out that total area of the top and the bottom, I just need to multiply this by 2. Now, let's look at the front and the back. The front and the back is this. What are the dimensions of that purple rectangle? 2.5 and 5. So we just multiply 2.5 times 5 to get the front, but then we do what to get the back as well? Multiply that by 2. Lastly, you have the left and the right hand side. The right, what are its dimensions? 3 and 5. So you multiply those, but you have to multiply it by a to get the left side as well. You type that into your calculator, and you will have the surface area of this figure. 70? 77? 70 centimeters squared, because we cannot forget about our units.
It's still square, but it's the entire surface area.
Yes. Even if we were finding individual faces, those would technically be centimeters squared as well. And then we add all of them up together. Did anybody not get that number, or is anybody confused? Okay? Now with this one, we have a triangular-based right pyramid with all edges 5 centimeters. This is a triangular pyramid, which means its base is in the shape of the triangle. Okay? And all the edges are 5. Okay? This is what you call a regular pyramid. Okay, all the edges are the exact same. So one side is 5, the rest of them are all 5. Okay? Now, how do you find the area of a triangle?
1/2 base times height.
1/2 base times height. Or the same thing. Or
Wait. Area was 1/2 AB. They're different. Sine C.
1/2 AB sine C. You guys remember that from the last unit?
No.
Yes. It's in the reference sheet.
It is in the reference book. It is in the reference book. But this can also, save you a little bit of time with triangles like this, okay? Because first off, what type of triangle is that?
A good old equilateral.
Equilateral, which means if all the sides are equal, all the angles are what?
Equilateral.
Equal angular.
Equal angular.
So what measure is this?
60 degrees.
If you're wondering where does 60 degrees came from, well, there's 180 degrees in a triangle.
And
Divide that.
There's 3 angles. And so, to be honest, if we wanted to do it the way of 1/2 base times height, we would have to basically split this in half. We would have to, and then we would have to figure out the height either using special right triangles or using SOHCAHTOA. Now, granted, there's nothing wrong with doing that. However, this is a little bit shorter. Because all we do is we plug into the formula at this point. What's the formula?
Cosine
So AB is referring to the side lengths, which are what?
5.
5 and 5. And then it's going to be the sine of angle 60. This is how you find the area of this triangle. But before we type that into our calculator and get a number, this is the surface area. This is the area of one triangle. How many triangles make up this pyramid? 4. So we're technically going to multiply this by 4. Okay? So now we can go to our calculator and get our answer. Yes? Yes. You can do half of 4 to get 2. That's a 5. Okay. So you're typing this into your calculator to get an answer. And yes, I want everyone to type it in.
Wait, why would you say square?
Because.
Oh my God.
Oh, yeah.
And area is always square meters, square units. All right, your curved face solids, okay? You have a cylinder. Remember, all of these solids have a curved face, okay? The cylinder is 2 pi r h plus 2 pi r squared. Your cone, pi r l plus pi r squared. And your sphere, 4 pi r squared, where r is your radius, h is your height, and l is your slant height, which only applies to your cones. Basically, it's the height that runs along the side of your cone. Now realize you may be asked to find the curved surface area in a particular problem, and that just literally means the curved part, okay, not the bases. So I went ahead and I boxed that in orange, and so if it ever asks you to find the curved surface area, also known as the lateral area, back from your geometry days, it's just the 2 pi r h for a cylinder, or just the pi r l for a cone. Okay? So it's those formulas without the base. Now, my question to you guys is this in your reference book? Does anybody have it?
Yes.
It is? All the volume ones?
Well,
Curved surface.
curved surfaces are in there.
Okay, so these are in your reference book, but not for your pyramids or your prisms, which basically means that you have to remember surface area is just the sum of all the bases. Okay? So, we're going to look at 2 examples and then we're going to do some practice. For each of these solids, we're going to calculate the area of the curved surface area, and then we're going to find the total surface area. Okay? You guys want to try this on your own? I mean, it's pretty straightforward. Okay, I'm going to let you guys try this one on your own. Give you about 5 minutes. All right, so the area of the curved surface is basically just talking about this middle part right here. What's the formula for the curved surface?
2 pi r.
Okay, your radius is what? 2.5. Do not let that throw you off. It is 2.5, and the height is 4. Okay, so you type that in, and you get what?
52.8.
Okay, if it asked you to leave it in terms of pi, what would the answer be then?
62.8 pi.
2 times
That would be
2 pi 4.
It'd be 2.8.
that would be 20 pi.
It would be 20 pi, because, and you would of course include your units, so
You're
your
dividing
square.
pi out.
Because you leave pi out if you want to leave it in terms of pi. It's just 2 times 2.5 times 4.
Oh, I thought 4 times 2.5 was 12 for some reason.
Alright. And then part 2 says to find the total surface area, which is basically the curved area plus the top
And the bottom.
and the bottom. Huh? So you have 2 bases that are both circles. The radius is 2.5, so you just square it and add it to your previous answer. We'll leave it exact so we don't have any rounded approximated areas here. So what you guys get for that?
102 centimeters squared.
Questions?
None. So when I'm looking for the total surface area, that's when I use
The full thing. Now realize that in the reference booklet, and somebody back me up on this, Brian, you have yours out, right? The formulas just gives you the full volume, correct? So it does give you the area of the curved surfaces.
It gives you the curved surface areas, not the.
It gives
not
you the
base.
surface area of the sphere, but nothing else.
Okay.
But you
Well,
already,
it says
but it gives you area.
area of a curved surface of a cylinder, area of a sphere, area of the curved surface of a cone, and then all the volumes.
Okay, so it does cover you. So if it does ask this question, you do have the formula there. All right. So one thing you do need to recognize with this particular problem is that the 8, that is not the slant height. If it was, it would have ran along that side. But 8 actually represented your regular height. That was 8. Okay. So to find your slant height, to find your curve area, is to do what? Pythagorean theorem.
Or just recognize that it's a spectral array.
Or not special right, but Pythagorean triple.
That's what it is.
It is a Pythagorean triple. 6, 8, and 10. This was 10. Or you can do Pythagorean theorem either or, you can still give 10. Okay? So then to find the area of your curved surface, it was pi RL, correct? So pi times 6 times 10, which is
188.
188.
Yeah, 188. Also 189.
No.
Oh, no.
188.
Oh, yeah.
It's so
God.
close to be.
Because it's 16 times approximately 3. So.
Now, if you wanted to, you could leave it exact, and it still be the right answer. If I asked you to leave it exact, what would the answer be? 60 pi. You just have to remember to include your units, and that would suffice as well. But remember, the direction on every test says, unless otherwise stated, leave answers exact or correct to 3 significant figures. So if you wanted to, you could just multiply 6 and 10, 60 pi, and call it a day. Include your units and then call it a day. Okay? Hell yeah, dude. All right. To find the actual surface area, though, you take 60 pi, which is your lateral area, and add it to what?
Pi r squared.
Pi r squared. What's your radius?
6. 36.
So you have 60 pi plus 36 pi, which is technically what exact?
96 pi.
So you could leave it like this, include your units, and you're done. Or if you could round up 3 significant figures, you would get what?
302 squared.
301. 303. Yeah,
So round up to
303.
So, with that being said, if you know that you've lost your rounding point on homeworks and tests, then it might be to your benefit just to multiply the numbers and leave the pi. It might be to your best interest, okay? Unless it specifically tells you to round to the nearest tenth or the nearest whole number, then you actually have to do it all the way out. Yes.
So for the first part, because we're finding the curved surface, we have to find.
That's not, exactly. So that wasn't given to you. That 8 was just the height. Okay? Questions on surface area?